This topic is about identifying turning points using the first derivative of functions and then identifying the nature of each turning point by using the second derivative of functions. So let's go through some theory first. So if we have this, which is the minimum point, somewhere here, then we know the gradient at the start of this curve is negative. At the minimum point is 0. And then on the right hand side, straight after where it goes 0 is positive. So if we were to draw the gradient function, because the first part is negative, it means it's going to be below the x-axis. Then it's 0, so it's going to intersect the x-axis at that point, and then it's positive, so it's going to be above the x-axis. So the gradient function looks like so. So this is f dash of x. Now, if you look at the gradient of f dash of x, then you can see it's always going up, so it's positive everywhere. So the gradient is greater than 0 for f dash of x, so for this gradient function. So f dash of x is always increasing, so it's an increasing function. Therefore, the gradient of the gradient function, which is f double dash of x, is greater than 0. So because of this, that means f double dash of x is greater than 0 for a minimum point. In a similar way, if we look at the maximum point, then at first we can see the gradient is positive, then it's 0, then it's negative. So if we draw the gradient function for f of x, then because it's positive first, it will be above the x-axis, then it's 0, so it's going to intersect the x-axis, and then it's negative, so it's going to be below the x-axis. So if we were to sketch this, we go from negative to positive. Okay, and this is the gradient function, so this represents f dash of x, and you can clearly see it's negative. The gradient is negative throughout. So gradient is less than 0 for f dash of x, which means f dash of x is strictly decreasing. I should have said strictly here. Therefore, f double dash of x must be less than 0, which means f double dash of x is less than 0 for a maximum point. And that is the theory we use to determine the nature of turning points. So whether it's a minimum or a maximum. Now, we won't go into too much detail about points of inflection because it gets quite complicated, but we'll look at example rates. It is demonstrated what you do in a point of inflection. So it said, let's go to the first example. Find and determine the nature of the stationary points for the following functions. Function y is equal to 2x cubed minus 3x squared minus 12x plus 4. So the first thing we need to do is, because we're trying to find a stationary point, we need to differentiate. So dy dx will be equal to 6x squared minus 6x minus 12. So we know dy dx is equal to 0 at stationary point, which implies 6x squared minus 6x minus 12 is equal to 0. If we divide by 6, I get x squared minus x minus 2 is equal to 0, which can be factorized to x plus 1 times x minus 2 is equal to 0, which means stationary points are at x equals minus 1 and x equals 2. So when x equals minus 1, we need to find the y value. So y will be equal to 2 times 1 minus 1 cubed minus 3 times minus 1 squared minus 12 times minus 1 plus 4, which gives us a value of 2. That is incorrect. Let's try that again. So I get 2 times minus 1 cubed, which is minus 2. Minus 3 times minus 1 squared is minus 3, which is minus 5. Minus 5 plus 12 is 7. 7 plus 4 is 11. Sorry, so y is equal to 11. For x equals 2, you substitute into y, which is this one, by the way. So y is equal to 2 times 2 cubed minus 3 times 2 squared minus 12 times 2 plus 4, which is equal to 16 minus 12, which is 4. 4 minus 24 is minus 20, plus 4 is minus 16. So that means the stationary points are minus 1, 11, and 2, minus 16. Okay, in order to find out whether it's a maximum point or a minimum point, we need to differentiate again. So we need to find the second derivative. So the second derivative of 6x squared minus 6x minus 12 is 12x minus 6. And then we need to see what happens to the second derivative when x is equal to first minus 1, which means I get 12 times minus 1 minus 6, which is equal to minus 18, which is less than 0. Therefore, minus 1, 11, because it's less than 0, is a maximum point. Is a maximum point. Now, so again, you need to substitute x is equal to 2 into the second derivative. So you get 12 times 2 take away 6, which is equal to 18. That is greater than 0. Therefore, the point 2 minus 16 is a minimum point. So as you can see, if we were to look at step by step what I did, so to find the first stationary point, we need to find dy dx. Then we need to equate dy dx to 0 to find the x coordinates for which we have the stationary points. Substitute this into the original equation, so that's very important. So whichever function you were given at the beginning, you need to substitute into that to find the y coordinate. To find the nature of the stationary point, you need to find the second derivative. Sub x into the second derivative. If it's greater than 0, it's a minimum point. If it's less than 0, it's a maximum point. There's one other important thing you need to take care of. Do not worry about this in this current lesson, but if dy dx is equal to 0, and the second derivative is equal to 0, but the third derivative is not equal to 0, then the point is a point of inflection. Okay. So if the second derivative is equal to 0, but not the third. Okay, let's look at another example, which is a bit more complicated. So y is equal to 4x squared minus 1 over x, which can be rewritten as 4x squared minus x to the minus 1 in index form. The first thing I need to do is find the derivative of this. 4x squared differentiates to 8x, and minus x to the minus 1 differentiates to plus x to the minus 2. Okay, and I know that dy dx is equal to 0 at stationary point, which means 8x plus x to the minus 2 is equal to 0. I don't like the look of x to the minus 2, so if I multiply through by x squared, I end up getting 8x cubed plus 1 equals 0, which means x cubed will be equal to minus 1 over 8, if I rearrange it, which means x will be equal to the cube root of minus 1 over 8, which is equal to minus a half. When x is equal to minus a half, y is equal to, going back to the original equation, 4 times minus a half squared minus 1 over minus a half. From the first term I get 1, the second term I get 2, 1 plus 2 is 3. Okay, therefore minus a half 3 is a stationary point. Now we need to determine the nature of it. The first thing I need to do is work out the second derivative, which is d squared y over dx squared. So if I differentiate again, I get 8 minus 2x to the minus 3. So if I work out the second derivative when x is equal to minus a half, I get 8 minus 2 times minus a half to the minus 3, which gives me 8 plus 16, which is 24, which is greater than 0. Therefore, minus a half 3 is a minimum point. Next example, find the coordinates of the points where the gradient is 0 on the curves with the given equations. Establish whether the points are local maximum points, local minimum points, or points of inflection in each case. So let's call it A, B, and C. So with A, first thing I need to do is differentiate it. So dy dx will be equal to 1 minus 2x. And remember, dy dx is equal to 0 at stationary point, which implies 1 minus 2x is equal to 0, which if I do a rearranging, 2x is equal to 1, so x is equal to a half. Now if x is equal to a half, I know y would be equal to 9 plus a half plus, minus a half, minus a half squared, which is equal to 9 plus a half is 9 and a half, minus a quarter is 9 and a quarter. 9 and a quarter can be written as 37 over 4. Okay. Now if I work out the second derivative, it's equal to minus 2. When you differentiate, you will get minus 2, which is always less than the 0. Therefore, the stationary point we got, which is x equals a half and y is equal to 37 over 4, is a maximum point. So that's A. Let's do B now. So y is equal to x plus 1 over x is the same thing as x plus x to the minus 1 in index form. So dy dx will be equal to 1 minus x to the minus 2. Dy dx is equal to 0 at stationary point, which implies 1 minus x to the minus 2 is equal to 0. If I times by x squared, then I get x squared minus 1 is equal to 0, which means x squared is equal to 1, which means x is equal to plus or minus 1, square root of 1, which is plus or minus 1. Okay, so when x equals 1, y is equal to 1 plus 1 over 1, which is equal to 2. And when x is equal to minus 1, y is equal to minus 1 plus 1 over minus 1, which is equal to minus 2. All I need to do now is determine whether this is a, so therefore 1, 2, and minus 1, minus 2 are stationary points. I need to determine whether the stationary points are minimum, maximums, or points of inflection. So that means I need to find the second derivative, which is equal to minus 2 x to the minus 3. So the second derivative at x equals 1 will be equal to minus 2 times 1 to the minus 3, which is equal to minus 2. Did I do the right thing? I've made a mistake here. I just realized, so let's start again here. So I'm differentiating 1 minus x to the minus 2. So let me just highlight it. So I'm differentiating this term, this expression, sorry. So I get positive 2x to the minus 3. So the second derivative when x equals 1 is equal to 2 times 1 to the minus 3, which is equal to 2, which is greater than 0. Therefore, 1, 2 is a minimum point. And if I do the same thing, which is d second derivative with x is equal to minus 1, I get 2 times minus 1 to the minus 3, which is equal to minus 2, which is less than 0. Therefore, minus 1 minus 2 is a maximum point. Okay, let's do C here. So y is equal to x to the power of a half times x minus 6. If you expand that out, it becomes x to the power of 3 over 2 minus 6x to the power of a half. If we work out dy dx, 3 over 2 times x to the power of a half minus 6 times a half is 3, x to the power of minus a half. Dy dx is equal to 0 at stationary point, which implies 3 over 2x to the power of a half minus 3x to the minus a half is equal to 0. I'm going to multiply by x to the power of a half to make this easier. So I end up getting 3 over 2x minus 3 equals 0, which means 3 over 2x is equal to 3, which implies half x is equal to 1, which means x is equal to 2. If x is equal to 2, then y will be equal to 2 to the power of a half times 2 minus 6, which is equal to minus 4 root 2. I need to now work out, so therefore 2 minus 4 over minus 4 root 2 is a stationary point. If I work out the second derivative now, I end up getting 3 over 4 x to the minus a half. Minus 3 times minus a half is positive 3 over 2. Positive 3 over 2 x to the power of minus 3 over 2. So I need to work out the second derivative when x is equal to 2. So I get 3 over 4, 2 times 2 to the power of minus a half, plus 3 over 2, 2 to the power of minus 3 over 2. Now if I input that into my calculator, I'm getting a value of, I'm just using the value to determine whether it's a maximum or minimum point. So something like this, which is greater than 0. Therefore, 2 minus 4 root 2 is a minimum point because it's greater than 0. That would be it. Let me just separate it out. Okay, next example. By considering the gradient on either side of the stationary point on the curve y equals x cubed minus 3x squared plus 3x, show that this point is a point of inflection. Sketch the curve y equals x cubed minus 3x squared plus 3x. Okay, so first thing I need to do is find dy dx. So dy dx is equal to 3x squared minus 6x plus 3. So I know dy dx is equal to 0 at stationary point, which implies 3x squared minus 6x plus 3 equals 0. If I divide by 3, I get x squared minus 2x plus 1 equals 0, which means x minus 1 times x minus 1 is equal to 0, which implies x is equal to 1. x is equal to 1, y would be equal to 1 cubed minus 3 times 1 squared plus 3 times 1, which is equal to 1. So therefore, 1, 1 is a stationary point. Okay, it says, by considering the gradient on either side of the stationary point. So what we need to do is, we know 1, 1 is a stationary point, so we need to go just before 1, find x value just before 1 and x value just after 1. So by considering x equals 0.99, which is just a bit less than 1, then dy dx will be equal to 3 times 0.99 squared minus 6 times 0.99. So it's minus 6 times 0.99 plus 3 is equal to 3 times 10 to the minus 4, which is greater than 0. If I consider x just a bit more than 1, so x is equal to 1.01, then dy dx will be equal to 3 times 1.01 squared minus 6 times 1.01 plus 3, which equals, again, 3 times 10 to the power of minus 4, which is greater than 0. Therefore, the gradient is positive 0, positive around stationary points. So on either side of the stationary points, the gradient is positive. So therefore, this implies that 1, 1 is a point of inflection, because there hasn't been a change in gradient, change in sign of the gradient. So it's just gone from positive to 0 to positive. The last part says sketch this curve. So if I sketch this curve, then I know there is the y-intercept, so x and y-intercepts goes through the origin because there is no constant at the end. There's a point of inflection at 1, 1. So at 1, 1, I'll call it 1, 1. So it looks something like this. So this is y is equal to x cubed minus 3x squared plus 3x. So that's a rough sketch. Okay, next question. Find the maximum value and hence the range of values for the function f of x is equal to 27 minus 2x to the power of 4. Okay, so first thing I need to do is find the gradient function. So f dash of x is equal to, if I differentiate it, the first term disappears, the second term will be minus 8x to the power of 3. Okay, so at maximum point, so because it's a maximum value, so at maximum value, f dash of x will be equal to 0, which implies minus 8x cubed will be equal to 0. That means x cubed is equal to 0, which implies x is equal to 0. X is equal to 0, then f of x, which is y is equal to f of x, will be equal to 27. Well, f of 0, f of x, which is f of 0. Okay. Now, if I want to find find the second derivative, the second derivative is minus 24x to the power of 2. Now, the second derivative at the point x equals 0 will be minus 24 times 0 squared, which is equal to 0. So which doesn't tell us much, because the second derivative is equal to 0. It doesn't tell us if it's a maximum or a minimum point. So what we need to do in this case is, because, therefore, 0.27 is a stationary point, because we can look at either side of 0 what's happening. Okay, so first thing I need to do is work out f dash of 0.01, which will be equal to minus 8 times 0.01 to the power of 3, which is equal to minus 8 times 10 to the minus 6. It's a negative number, so it's less than 0. And then I need to work out a number on the other side of 0, which is negative 0.01. So a number on either side of 0 0.01 and negative 0.01, which is equal to, minus 8 times negative 0.01 to the power of 3, which gives me a positive number, 8 times 10 to the minus 6, which is greater than 0. Therefore, the gradient, so obviously in order, this is the smallest value, that is the second smallest value, that is the third smallest value. So the gradient is going from positive to 0 to negative, yeah? Gradient is positive, 0, and then negative. So if we look at the graph, it's going like so, up positive, then 0, then negative. So therefore, you know that 0.27 is a maximum point, because you can see from the diagram, it's a maximum point. Which means the range of values, it's a maximum point, that means the highest y value it reaches is 27. Therefore, y is less than or equal to 27, which implies range of values for f of x is less than or equal to 27. Okay, one last example that I'm going to go through. So f of x is equal to blah, blah, blah. Find the coordinates of the stationary points of f of x and determine the nature of each. Okay. So this is a quartic. So this example might be quite long. So the first thing I need to do is f dash of x, work out the derivative of f of x, which is 4x cubed plus 9x squared minus 10x minus 3. At stationary point, minus 3. At stationary point, dy dx, which is equal to f dash of x, in this case, is equal to 0, which implies 4x cubed plus 9x squared minus 10x minus 3 is equal to 0. Okay, if I substitute, so now I know it's a cubic, so if I need to solve cubic, I need to use trial and error to find a root of this equation. So I'm going to substitute x equals 1. So it looks like it's going to work out. Substitute x equals 1. Then I get 4 times 1 cubed plus 9 times 1 squared minus 10 times 1 take away 3 is equal to 4 plus 9, which is 13, minus 13 is 0. This implies that x minus 1 is a factor by the factor theorem. So if I want to find the other factors, I need to divide 4x cubed plus 9x squared minus 10x minus 3 by x minus 1. So x times what gives me 4x cubed? It must be 4x squared. 4x squared times x is 4x cubed. 4x squared times minus 1 is minus 4x squared. I need to subtract this, so this becomes a minus, that becomes a plus. So I end up getting 13x squared minus 10x minus 3. X times what gives me 13x squared? It must be positive 13x. So I end up getting 13x squared when I multiply it, then minus 13x. Again, I need to subtract it, which means I get a plus here. I end up getting 3x minus 3. Positive here, 3 here. 3 times x gives me 3x. 3 times minus 1 gives me minus 3. Again, when I subtract it, I get 0. So that does work out. So that means 4x cubed plus 9x squared minus 10x minus 3 is equal to x minus 1 times 4x squared plus 13x plus 3. And if I factorize out this quadratic, then I know it's going to be 4x in one bracket, x in the other one, plus 3 here, because then I get 12x, plus 1 here, because then I get x, which gives me the 13x in the middle. Therefore, x is equal to 1 is a root, x is equal to minus a quarter and x is equal to minus 3. Okay. So when x equals 1, y is equal to 1 to the power of 4 plus 3 times 1 to the power of 3 minus 5 times 1 squared minus 3 times 1 plus 1, which means I get 1 plus 3, which is 4. 4 minus 5 is minus 1, minus 4 plus 3, which is minus 3. Okay, so therefore 1 minus 3 is a stationary point. Okay, in a similar way, when x equals minus a quarter, if I substitute x equals minus a quarter into y, f of x, then I get y is equal to minus 55 over 4. No, that's not right. Let's just do it the long way. So y would be equal to a quarter to the power of 4 minus 3 times a quarter to the power of 3 minus 3 times a quarter plus 1. If I put that into my calculator, I end up getting 357 over 256. Therefore, minus a quarter, 357 over 256 is a stationary point. The last one I need to substitute in is when x is equal to negative 3, y will be equal to negative 3 to the power of 4 plus 3 times negative 3 to the power of 3 minus 5 times negative 3 to the power of 2 minus 3 times negative 3 minus 1, and it gives me a value of negative 35. Therefore, minus 3, negative 35 is a stationary point. Just realize I missed a term here, which is minus, I'm just going to have to write here, 5 times a quarter squared. Okay, that's it. And now that I've got all these points, I need to find out whether they are a maximum, minimum, or a point of inflection. So first thing I need to do is find out the second derivative. So f double dash of x is equal to 12x squared plus 18x minus 10. So I need to do f double dash at x equals 1 is equal to 12 times 1 squared plus 18 times 1 minus 10, which is equal to 20, which is greater than 0. Therefore, 1 minus 3 is a minimum point. F double dash of the second stationary point, which is minus a quarter, is equal to 12 times minus a quarter squared plus 18 times minus a quarter minus 10, which is equal to minus 55 over 4, which is less than 0. Therefore, minus a quarter, 357 over 256 is a maximum point. And the last one I need to substitute in is minus 3, which is 12 times minus 3 squared plus 18 times minus 3, take away 10. I put that into my calculator, I'll get 44, which is greater than 0. Therefore, minus 3 minus 35 is a minimum point. Okay, that's it. So part B, sketch the graph of y equals f of x. Okay, so you know that there's a 1 there, so that's going to be a y-intercept. So it goes through there at 1. You know there's a minimum point at 1 minus 3. 1 minus 3 is somewhere here. There's a minimum point there. It's a positive quartic graph, so it's going to look like a W this way. Minus 3 minus 35. So it's a rough sketch. It's going to also be a minimum point. And let me just write that 5 clearly. And the maximum point is at minus a quarter and positive 3 for somewhere here. Minus a quarter, 357 over 256. Okay, so that's how it looks. That means that this -3 -35 is a minimum point. So remember, it starts off with quadrant 2. There's a minimum point there. Then it's going to go to a maximum point of minus a quarter, 357,256. It's got a y-intercept of 1. Then it's got a minimum point at 1 minus 3. So it's going to look like that. So this is y is equal to f of x. Something. It's a rough sketch. I've labeled the maximum and minimum points. That's enough. And the y-intercept. I don't need to find the x-intercepts because it doesn't say label the x-intercepts.